All right, we're recording. So we're talking about arithmetic combinations. Boy, that is not pretty, huh? Combinations. I'll get better at it as we move. Of functions. Look, I'm already getting better with it. It's already starting to look a little nicer. Basically, what those arithmetic combinations are adding, subtracting, multiplying, and dividing. Or, as we like to call them in math, mathematically, sum, difference, product, and quotient functions, right? When we're talking about this, we're going to use two different functions. We're going to let f and g be functions, right? What functions? I don't know, right? They could be anything. When we're talking about sum of functions, it means addition. And so we're saying that if we have a function f plus a function g of x, that means the variable on both of these is x. It's the same as saying that f of x plus, plus that's not right. Oh, did you see that keyboard pop up? That's a new thing. Trying to erase here though. It only lets me erase like one piece at a time. There we go. And g of x, right? What that means ultimately is that I could take whatever these things are equal to and just add them together. I'm going to get all of these written down and then we'll look at it in terms of problems. In the same respect, if we had a difference, not as pretty. If we had f minus g of x, we could break that down as f of x minus g of x. Oh my God, it is so crazy in here. Like it is hard to focus with all of that going on in the background. I'm going to like have to start finding another place to work on Mondays and Thursdays, I think. Like I need a different room. This is crazy. Product is multiplication. It really is. I'm sorry. I hope my video isn't picking all of this up too. It's absolutely insane. And I'm sure their classes are getting the same thing, like they're hearing all three of us. Product says that if we have function f times function g of x, it's the same as f of x times g of x. Holy cow, it sounds like they're fighting with each other in the background over who gets to teach, And last, we have our quotient, which is just f over g of x. What's nice about this is it's just f of x over g of x. This is the easiest one because we really don't break it down. So let's look at examples, and hopefully we can get through these examples quickly because it's getting loud over there. Like they're getting a little crazy. They're like right next to each other with no barrier. I have some barriers put up in mine. Like you could see if I'm going to turn my camera so you can see. Like I have a little wall right there. And they're both on the other side of it. But they're literally like one on that side of the room, the other on that side of the room. Like I really got the best space in here because I can't have anybody over in front of me because there's a door there. So I get all this space to myself. So let's talk about examples and see how this looks in real time, right? Um, so if I have some kind of a function f of x set equal to something, and say it's what I have it equal to is 2x plus 1. And I have a g of x that's equal to x squared plus 2x minus 1, right? Two different functions. And I want to find f plus g of x, right? Ultimately, all that means is I am going to take my f of x and I'm going to add it to my g of x. So I'm going to have my 2x plus 1, and it is going to be plus x squared plus 2x minus 1. And now when we're adding, you notice I put everything into parentheses, and when we're adding, parentheses don't make much of a difference. I always put stuff in parentheses to start, because if it's subtraction, it would make a difference. So there are circumstances where it does make a difference, and I want to keep that in mind, which is why I always put things in parentheses when I'm substituting something in. But because of this, because it's addition, everything could very easily just come out of the parentheses, and it wouldn't make any difference whatsoever, right? I could write it like this and it would be fine because it's just addition. And all we would have left to do is combine our like terms. And if you remember correctly, we always write these in terms of their powers. We do the higher powers first. So here I have x squared. Then I have two x terms. I have 2x plus 2x. Well, that's plus 4x. And I have 1 minus 1, which is just 0. So this would be our final outcome on that. But it's literally, we're just adding those two functions, right? In the same respect, if I'm doing like a difference problem, like if I had, let's do a different color just for funsies. Let's do a little green. Let's go green. Everybody's talking about it. Everybody's going green these days. If I had, for example, the same problems, we're going to use the same f and g of x, right? I have a g of x that equals x squared plus 2x minus 1, right? Call that g. I'm losing my mind today. The only problem with this new whiteboard is that when I turn my pen upside down, it's supposed to be an eraser, and it doesn't work on this. I have to like go click it every time I want to erase something. So this is my g of x, right? My g of x equals x squared plus 2x minus 1. My f of x, what did it equal? It equals 2x plus 1. And we want to find f minus g of x. And we're going to do the same thing we did the last time. But if you remember, the last time I said we were using parentheses, right? And the reason that we were using parentheses was because you never know, like, am I going to be subtracting it? Is there something I'm going to have to distribute through this? So it says f minus g of x, which means f is first, right? We're going to have our 2x plus 1 minus our x squared plus 2x minus 1. And this minus has to get distributed to each part before we can pull it out of the parentheses. So our 2x plus 1 is going to stay the same. I'm going to have 2x plus 1. But then I'm going to have minus x squared. I'm going to have minus 2x. And I'm going to have plus 1. And now I can combine all of my like terms, and I'm going to start again with the highest power, which is that negative x squared. And then I have 2x minus 2x. Well, those cancel out, right? 2x minus 2x is no x's. And then we have 1 plus 1, which is plus 2. So as you can see, we have a very different answer from the addition, right? When we added them together, we wound up with, I don't remember what we wound up with, but when we subtract them, we wind up with minus x squared plus 2. So let's look at our next problem, which I'm guessing you guys can figure would be multiplication, right? I feel like multiplication should have a purpley color. That's more pink. I want to go purple. Let's see, do we have a purple in here? Let's we'll go like this kind of purple right here. I like that. That's a good one. So our next example is we're going to be given different functions this time. We're going to have an f of x that equals x squared and a g of x that equals x minus 3. And we want to find f times g of x. So, same thing as before, right? We're going to take our x squared, right? That's our f of x, and we are going to multiply it times our g of x. Now, when we multiply something into a binomial, this is the binomial. It's bi because it's got two parts, right? If you remember correctly, we have to distribute into that. We can't just multiply it times the x. We also have to multiply it times the 3. So when I look at this, this is going to be x squared times x, which is x cubed. And then we're going to have x squared times negative 3, which is minus 3. I still have to figure out how I'm opening that. I don't know how I'm doing it yet. But look, it like left me a thing that I don't want. There it is. X squared times negative 3 is negative 3x squared. And that would be our final answer. Like, we can't combine those anymore. You can't combine an x squared and an x cubed because they're not like terms. And so that would be a sufficient answer. So if you could see this, like, none of this has been particularly difficult, right? Like, we haven't done anything super complicated. I always think myself that this is the one time that division is the easiest part of what we're doing. And I'm going to try to make sure that you guys can still see what we were doing. Let's do orange. I love orange. It's one of my favorite colors when it comes to writing on boards. When we're looking in terms of the quotient, if I have to find f over g of x, and I'm given and f of x that equals, oh, this one's interesting, the square root of x, and a g of x that equals 4 minus x squared, the square root of 4 minus x squared. If I want to find f of g of x, it is literally f of g of x equals the square root of x over 4 minus x squared. That's it. Pretty tough, right? It's tough stuff. If I asked you for g over f of x, that would be 4 minus x squared over the square root of x. So not too difficult, right? If I was looking at, well, everything else kind of works the same both ways. Like if I asked you for g times f instead of f times g, it's going to be the same thing, right? Because multiplication, doesn't matter which way you multiply, you're going to get the same answer. 2 times 3 is the same as 3 times 2, right? Same thing with addition and subtraction. Well, not so much subtraction, as long as you keep the minus in the right spot, right? They alternate. So what you're going to have in terms of your homework is, I'm going to go to it right now so you can see. Now, it's going to look different for me than it does for you because mine are all put together, but the problems will be the same, sort of. Is you're going to get stuff like this where it's going to give you a problem and it's going to ask you, you'll notice I only assigned you 4, but because each 4 asks you the same thing. What is f plus g? What is f minus g? What is f times g? And what is f divided by g? All 4 problems are going to ask you the addition, the subtraction, the multiplication, and the division. So I felt like you were getting kind of 4 problems with each problem. So I didn't want to over assign them. But they're all going to kind of work like that. When I see you guys on Thursday, we'll move into the second part where we're doing the composition of functions, where we're putting functions into other functions, which gets a little bit more complex. But I didn't feel like I could teach you that and this all in one day. I just didn't feel like there'd be ample time for that. So we broke it up a little bit. I don't foresee you guys having too many problems with it. Like you can see here again, same thing. Here again, same thing, right? If you look at these, my x squared and my f of x and my g of x is literally just x squared over whatever g of x is. It's not going to weigh you down. These problems shouldn't take you too long to get through. I do highly recommend, though, that you do them kind of soon while you remember everything, because I always think that's the best way to practice. But aside from that, I think we're good to go. I don't see any issues with that. I think